Most gardeners are told that successful plant propagation depends on chemicals, powders, gels, and liquids that promise higher success rates, faster roots, and professional results. They are sold as essential tools, something you must buy if you want your cuttings to survive. But what very few people are told is that plants learned how to root long before humans learned how to sell it. Long before laboratories, patents, or bottles, plants were already sharing this ability with one another, quietly and consistently, in ways that still work today. What if the most reliable rooting method does not come from a store shelf, but from another plant? What if the reason it works has nothing to do with branding or precision dosing and everything to do with biology that has existed for thousands of years? This is the rooting method that works without chemicals, that requires no purchases, and that almost nobody uses anymore. Long before commercial rooting hormones existed, gardeners noticed patterns. Cuttings planted near certain trees rooted faster. Branches pushed into damp soil near riverbanks seemed to come alive on their own. Some plants, when damaged, responded not with decay, but with explosive root growth. These observations were not accidents. They were early glimpses into a natural system that plants use to communicate growth signals through chemistry. Among all trees, willows stand apart. They root with almost no effort. A broken branch stuck into moist soil often survives, producing roots where there should be none. This behavior is not luck. It is the result of an unusually high concentration of natural rooting compounds in young willow growth. When willow tissue is damaged, it releases these compounds into its surroundings, influencing not only itself but nearby plants as well. The key compound involved is indole 3-butyric acid, commonly known as IBA. This molecule is the backbone of nearly every commercial rooting hormone sold today. What many gardeners do not realize is that IBA was not invented in a laboratory. It was identified there. Its original source is biological, and willows produce it in abundance, particularly in their young, flexible shoots. IBA works by changing the fate of plant cells. When a cutting is taken, the plant attempts to seal the wound to prevent moisture loss and infection. At the same time, it must decide whether survival is possible. IBA interferes with this decision. It reprograms stem cells at the cut site, redirecting them away from sealing and toward root formation. Instead of closing down, the plant opens up a new growth pathway. But willow offers more than IBA alone. It also contains salicylic acid, a compound better known to humans as the basis for aspirin. In plants, salicylic acid plays a protective role. It suppresses decay organisms, reduces stress responses, and slows the plant's instinct to rush wound closure. This delay is crucial. It keeps cellular pathways open long enough for IBA to do its work. This combination is why willow-based rooting methods often outperform single-compound commercial products. Synthetic rooting powders provide IBA, but they do not provide the biological protection that accompanies it in nature. Willow tissue delivers both at once, already balanced, already optimized through evolution rather than formulation. The method itself is surprisingly simple. Young willow shoots, not old wood, are the source. These are the flexible branches from the current growing season, usually green or yellow in color. They contain the highest concentration of active compounds. When cut into small pieces and soaked in water, their cell walls break down, releasing IBA and salicylic acid into the liquid. This liquid, often called willow water, is not a fertilizer. It does not feed the cutting. Instead, it acts as a signal. When a cutting is soaked in it, the plant interprets the chemical message as permission to grow roots. The cutting is not being forced. It is being encouraged to follow a pathway it already understands. The effectiveness of this method depends on understanding timing and plant physiology. The soaking period allows the cutting to absorb the compounds slowly. Overnight soaking is usually sufficient. After that, the cutting is planted normally, with no additional treatment. Root formation begins internally before anything visible appears above the soil. This method works particularly well on woody plants that are often considered difficult to propagate. Roses, berries, fruit trees, shrubs, and many ornamentals respond strongly because their tissues are already capable of producing roots, but are often blocked by stress responses. Willow compounds remove that blockage. One of the reasons this method faded from common knowledge is not because it stopped working, but because it could not be standardized or sold easily. A bottle has a price. A tree does not. As commercial horticulture expanded, methods that required no repeat purchases slowly disappeared from teaching programs, catalogs, and extension advice. But plants have not forgotten. Willows still grow aggressively along waterways and disturbed ground. They still produce the same compounds. The chemistry has not changed. Only awareness has. Using plant-based rooting methods also teaches an important lesson about propagation itself. Success is not about overpowering plants with inputs. It is about understanding how plants already function and working with those systems. When a method aligns with plant biology, it requires less effort, less precision, and fewer resources. There are limits, of course. Willow water does not replace good sanitation, proper cutting selection, or appropriate moisture control. It is not magic. It is biology. Used correctly, it improves consistency and survival rates, especially for gardeners who struggle with cuttings drying out or rotting before roots form. Another advantage is freshness. Commercial rooting hormones degrade over time, especially once opened. Willow water, when refrigerated, remains effective for weeks, and it can be remade as needed. There is no expiration date imposed by packaging, only by natural chemical stability. This method also removes the psychological barrier many gardeners feel when propagating. Without specialized products, propagation becomes less intimidating. It becomes something you can do with what is already growing around you. That shift alone often improves results because gardeners attempt propagation more often, learn faster, and observe plant responses directly. The most important takeaway is not that commercial products are bad, but that they are not the only option. Plants evolved long before industrial inputs existed. Many of their most powerful tools are still accessible, if you know where to look and how to use them. The rooting method that works without chemicals is not new. It is not hidden. It is simply quiet. It exists wherever willows grow, wherever plants interact, and wherever gardeners choose to pay attention to how plants actually behave instead of what they are told they need. What makes this method so important is not just that it works, but what it reveals about how much practical plant knowledge has been quietly sidelined over time. Willow water is not an alternative technology or a fringe experiment. It is a biological fact that predates modern horticulture by centuries. The hormones responsible for root initiation exist whether we acknowledge them or not, and plants have been using them long before laboratories learned how to isolate and name them. When we return to these methods, we are not rejecting science. We are applying it at its source. This understanding reshapes how we think about propagation itself. Instead of relying on shelf-stable products designed for storage and sale, we begin to work with living systems that regenerate themselves. A single willow tree can provide rooting hormone year after year without depletion, without waste, and without dependency. This changes propagation from a consumable process into a renewable one. It also encourages closer observation of plant behavior rather than blind reliance on instructions. Once you see how effectively plants manage their own chemistry, it becomes clear that many so-called advanced solutions are simply refinements of processes already perfected in nature. This realization has practical consequences beyond rooting cuttings. It shifts gardening toward resilience instead of replacement, understanding instead of purchase, and continuity instead of disposal. When gardeners adopt methods like willow water, they also adopt a mindset that values biological cycles over convenience packaging. They begin to ask why certain techniques disappeared, who benefits from their absence, and which forgotten practices might still be waiting to be rediscovered. This is not nostalgia. It is efficiency rooted in biology. As soil health, seed saving, and natural propagation regain attention, methods like this naturally re-emerge because they solve real problems without creating new ones. The quiet effectiveness of willow water is a reminder that progress in gardening does not always mean adding something new. Sometimes it means removing barriers that were never necessary in the first place. By understanding how plants already support one another chemically and structurally, gardeners gain more control, not less. They stop chasing products and start building systems. And in a time when sustainability is often discussed but rarely practiced at a fundamental level, returning to these biologically complete methods is not just practical, it is inevitable. The knowledge never vanished. It simply waited for conditions where it made sense to listen again. Once you understand this, propagation stops being a transaction and becomes a conversation. You are no longer buying success. You are participating in it. And the next time a cutting roots where you expected failure, you will understand why.